Okay, so today we are starting matrices. So matrices are made up a rectangular like brackets. So what they're talking about are things like this, the rectangular arrays or whatever. And they can be made up of numbers or they can be letters. So say I had this, I could have, or I could, and that, something like that. So what we say, so they've made up of that. We call these individual things in here, they're like, that's an element. So this matrix that I've just drawn up there has 4 elements. Now, in matrices, the shape or the order of the matrix is very important. If we know that, we know what things we can do with it. So the way we talk about the order of the matrix is that you say the number of rows by the number of columns. So what do I mean by that? So if you look here, this one has 2 rows and it has 2 columns. So when you are discussing the order, you write how many, you do the curly bracket and you write how many rows it has first. So for this one, it's a 2. Then you say it's a times or by, and then you say how many columns. So that's the rows and that's the columns. So this is a 2 by 2. Sort of like, you know, in a photograph when you go, oh, I've got a 10 by 15, yeah? So we're saying the rows and the columns. So you can, there we go. So say if I make up a matrix, often matrix are given a label of a capital letter. So say I said this was matrix H, okay? So if we went to say what the order of this one is, well, this one has 2 rows, doesn't it? So I'd say it's a 2 and it has 3 columns. So this one's actually a 2 by 3. Now I can say, if I want to go talk about one of the elements in that matrix, the way I'm going to refer to it is I'll use the little letter H, so I know you're talking about an element within that matrix that has the capital H, and I might say something like 2, 3. And when they say that, what they mean is they want you to go look at the element that's in row 2 and column 3. So for this case, that is equal to 1. So they might be talking about 1. So that's what they're talking about when they give those letters. So here in this example on our notes here, I don't know why they're using A when they called it E. So maybe this should have been called matrix A. Yeah, and they're saying that this is element A11, which is true. It's in row 1, column 1. They might not put the comma. See how I put a little comma there? Sometimes they do, sometimes they don't. So that can be a bit confusing because it looks like 13. It actually means row 1, column 3. Okay, so we have different operations that we can do with our matrices, obviously. And the first ones we're going to look at is addition, subtraction, and scalar multiplication. For you to be able to add or subtract a matrix, they have to be the same order. So you'd have to have, so if you look down here at this example here, if can you tell me what order is matrix A here? Looking up, what order is that? That is a 2 by 2. And what's the order of B? Is a 2 by 2. Good, 2 rows, 2 columns. Because they are exact same order, you can add them. And when you do add them, what you do is you add the same element from each spot. That's why they need to be the same order, otherwise you can't do it. So if I'm adding, matrix A plus matrix B, I'm going to get a matrix that has the same order, so a 2 by 2. So you know you're going to get a little answer here, 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 and here. So as I said, you add the same spot. So when we had 2 and 3, that would give you 5. If I do this spot, 6 and 6, that will give 12. if I do -1 and 1, what will that give? 0. Good. And 3 and 3 would give 6. So there you go. Okay, so that's addition. If you're subtracting, what do you think you do? You do the same thing, same spot, but you minus it. Yes? Okay, with the next one, this here is when we've got to times the matrix by 3. So what that really means is we've got 3 times, and I'm just going to actually write out matrix A there. So we've got 3 times. That's another way to say that. Okay, this is called scalar multiplication. Scalar multiplication is when it's just a number on the outside of that matrix. So just to be careful, if you have a quarter outside a matrix, that's still a scalar. So I just mean a number outside. It's not another matrix, it's a number. Okay, and this one's pretty easy. When you multiply, you just multiply everything in there by that number. So 3 times 2 would be 6. 3 times 6 is 18. 3 times -1 is -3, and 9. So there's your answer there. Okay, so if we go over here and do this one up here that I wrote. So what's a quarter times 8? So remember, what you're actually doing is a quarter times 8 on 1. So what would that actually equal?
8 over 4.
Yeah, which is?
2.
2. Good. So 8 over 4 is 2. What about 4 over 4 is?
1.
And then we'd have 3 over 4. We can't simplify that anymore, can we? And then 1 over a quarter. So that's how you could do a fraction 1. Same thing, you still follow the same rules, and off you go. Down here, when we have 2 times A, so what we're going to have to do here is actually multiply matrix A by 2 and also multiply B by 4, and then we'll work it all out. So cause grief anyway. If we multiply that out, we'd have, this one would be 4, 12, -2 and 6. And then I'm going to say minus, and I've got 12, 24, 4, and 12. And so here's a practice of a minus. So I'm going to go 4 minus 12. What will that equal? Good, -8. Then I've got 12 minus 24, -24. And then I've got the -2 minus 4, that'd be -6.
Yeah.
Yeah, good point. Do you mean there? Yeah, that's -12. Yep. And 6 minus 12, -6. Okay? Alright, so the next thing we're going to look at is multiplication of matrices. And what they actually mean by that is we're going to have a matrix and we'll times it by another matrix. So it's not just a number out the front now, it's another. Okay, so when we're multiplying 2 matrices, there's a set of conditions that have to happen. So what they're saying is the number of columns in the first matrix must be the same as the number of rows in the second matrix. So what they mean by that, if I wrote up here the order of matrix A, say it had m number of rows and n number of columns. I'm just saying, I don't know what it is. For it to happen, to be able to multiply, this needs to have the same n number of rows. So these 2 numbers essentially have to be the same, equal. And then what happens, so that has to happen for you to be able to multiply. And then once you multiply, so say that is, they equal each other. And if they equal each other, that means we can say it's defined and you can do it. And if that, so we multiply them together, we get this answer, AB. And what it will have, it'll have an order of m, whatever was there, so m rows, and then it will take the number of columns from the second. So that's how you know what the order is of your answer. So in matrices, though, you have to be really careful because in normal maths, if we say 3 times 1, it's 3, isn't it? And that is the same as 1 times 3, isn't it? Doesn't matter which way. In matrices, unfortunately, it does make a difference. So A times B does not necessarily equal B times A. Sometimes one way is possible and the other way isn't. And it will always be it's a different answer. Like it might, it doesn't necessarily be the same answer either. It could be, but it doesn't have to be. All right, so if you have a look here, down in this example, down here, it says, state whether the following matrices can be multiplied. If you see that can be multiplied, they'll say it's defined. Just get used to that word. Because you'll use this if you go on to do further or general maths as well, you'll need to know some of this. All right, so if we have a look, what's the order of this? We're looking here. What's the order of this first matrix? How many rows has it got? 2. And how many columns has it got? 3. Okay, this second one, how many? 3. It's got 3 rows and 4. So can you see this one is defined because they equal, don't they? And the answer, they just asked me they said what are the dimensions or the order of the resulting matrix. So when you multiply them together, what's the order going to be? It'll be a 2 by what? By 4. Excellent. So that's where we're taking that. All right. Now, if we do the second one here, so what's the order of this first matrix in this one? 3 by 3. Excellent. And what's it being multiplied with? A 2 by 3. Now, is this one defined? No. So we'd say no, not defined. So it won't be able to be multiplied. If you do them on your calculator, it will say not defined. Now, okay, so in this example, I'm going to show you how you can manually multiply these. So that means do this by yourself, because on the calculator, we can just type them in. But, so when we manually do them, you're going to have to do like what we just did. So check the order of the first matrix, which is what? 2 rows by 2 columns. And what's this one? Is 2 by 1. Now, can we multiply these? Yes, we can, because the number of columns, yes, in the first matrix equals the number of rows in the second. So that means, yes, we can multiply it. Yes, it's defined, okay? So if they ask you to say, is it possible, can you multiply this? That's when you say yes, because the number of columns in the first equals the number of rows in the second. In second matrix, yeah? So if you're asked to say why, that's what you need to write out. And you do get asked that sometimes. All right, so you have just worked out. Okay, so we have worked out that you can multiply them together. Now, let's think about what will our order be of our answer. When we multiply them together, we're going to take this rows and this columns, aren't we? Yeah. So we will have, a 2 by 1, okay? So when you're manually working them out, you should work out what your matrix at the end should look like. And what I often say is draw it up and put little blanks where it is. So I'm going to have 2 rows, so and 1 column. So I'll have an answer here and an answer here. Yeah, 2 elements. I'll have 2 elements in my answer. Okay, now the way you multiply is sometimes they call it run and dive. So what you're going to do is it means you run across the row and you go down the column. So if you have a look here, I am in row 1, column 1. So when I'm actually finding the answer, can you see this is row 1, column 1? Yes? So I'm going to be finding that answer. Now what happens is this 2 gets multiplied with the 3, and then the -1 gets multiplied with the 4. So you go run and dive. So what I'm doing is I'm going 2 times 3, and then you add the other one, which is -1 times 4. So if you were tidying that up, wouldn't that be 6 plus -4? What would that be? 2? 6 plus -4, yeah? And then if we go and do the next, so the next one, see how we are in row 2, column 2. So what we're going to do is we're going to go across, run across row 2 and down, that's column 1, column 1, yeah? So in this one, when we do that, the -1 will get times with the 3 and plus the 4 times the 4. So tidy that up, that would be -3 plus 16, which would be 13. Good. Alright, so let's do this second example again. So first, check your orders. So this one is a 2 by 2 with a 2 by 2. So it is definitely able to be done because it's defined. And my answer will be a 2 by 2 because of those two. So I'm going to write that I'm going to get a 2 by 2. And I'm going to prepare myself to see what my answer will be. So I'm going to have 2 rows and 2 columns. So I'll have a number along here, another number there, and so on. So you don't have to do this, but you just do it. It makes it a lot easier because you know what to expect, because sometimes you get a bit confused. So now we're going to do the run and dive. So up here, I'm in row 1, column 1. So I'm going to go row with column 1. So that will be 4 by 2 plus 1 times 0. Yeah? And I'll do a tidied up one over here. So 4 times 2 would be 8 plus 0. So that is 8. Okay, then now let's go. If I look here, I'm in this one. I'm in row 1 and column 2. So I'm actually going to go row 1, column 2. So it'll be 4 times -1 plus 1 times 6. So that will end up being -4 plus 6. So that would be 2. All right, now let's go down and do this one here. I'm in row 2, column 1. So I'm going to go row 2 with column 1. So it is 3 by 2 plus 2 by 0. So that ends up being 6. Okay, and then the last one here, we're in row 2 and column 2. So I'm going to go row 2, column 2. So it'll be 3 times -1 plus 2 times 6. So we end up with, what's that, -3 plus 12. Yeah, which is 9. Okay. All right, boys. So let's go practice this one more. So we have a 2 by 2 getting multiplied with a 2 by 1. I'm videotaping, boys. Yes, this is defined. And my answer will be a 2 by 1. So I type it up. I'm going to have 2 rows like that, and I'll have 1 column, sorry. So when we go to do the first one, so we'll go run and dive. So that will be 3 times x plus 1 times y. And then if I go to do the second one, and I go row 2, column 1, you'll see I'll have 4 times x plus 2 times y. So you can see if you tidy that up. Now, can I add x and y's together? No. So you end up with your element being an expression there, like that. This is still 2 elements, yeah? But it's an expression. So looking at that, that's what happened. See how it created an expression. So what we actually can do is you can use matrices to solve simultaneous equations. So okay, if you have a look, I'll show you how this is done. If you have a look, if I set up this matrix here underneath, and I'm going to show you. So what I'm going to do, I'll put I might not worry about the equal part. I'm just going to show you how that can be set up. Okay, if you have a look at this one, so it's like what we did up before. So if I do run and dive, and I'm getting my answer here. So what I'm going to end up with is 2x plus 4y, and then if I do the run and dive on this next one, I get 3x plus 8y. Can you see that I got the same equations, didn't I? Yes. So can you see how that's a way of setting up those equations matrix style? Yeah? So what have I done? I've essentially put the x's down this side, haven't I? Isn't that 2, yeah? And 3. And I put the y's here, and the same, see how it's gone x and y, and then the same orders happen down that way there. So you could set it up. So just to show you, if I had, say for example, if I was going to set this up in matrix form, I'm going to have a 3 by 3, yeah? And I'm then going to say it's going to be x, y, z. So across here, this one here, I'm going to have the numbers that are in front of those letters. So can you see this is x, y's, and z's. Now, 2, 1, -2. Here, they've swapped them around. So I have to swap them around in my matrix as well. So I have to put the y first, which is a -1 in front of it, and then do the z. So it's a little bit of a crash course just to help you, because you're going to need to know how to just set them up. But mainly we're going to be doing these ones. All right. You can